Okay, first we're going to be simplifying, multiplying, dividing rational functions. Most of our main issues in this section came from not correctly factoring. So what you want to remember is that when you factor, your answer should always be able to be multiplied back out to your original. So the numerator of my first fraction would factor to x plus 8 times x plus 5 over x minus 7 times x plus 5. Now, I didn't actually count off really for your excluded values, but your excluded values should be considered before you cancel anything. So my excluded values would be x cannot equal 7, x cannot equal negative 5. X plus 5s both cancel, so I get x plus 8 over x minus 7, and that is what I was looking for in your answer. This next one is tricky only because of the GCF. So most of us got that our numerator is a difference of squares, x plus 3, x minus 3. And a lot of you saw that I had a GCF in the denominator, but how you factored it out was wrong. So you want to think about dividing each term by 2. So 2x divided by 2 would be x, and 6 divided by 2 would be 3. So this means that x cannot equal negative 3, and when I simplify, I get x minus 3 over 2. This next one is just a whole bunch of GCF. So my first fraction, I have a GCF of 5, which leaves me with y minus 4. Then I have a GCF of 3, which leaves me with y plus 5. Then I have a GCF of 7, which leaves me with y plus 5. And a GCF of 10, which leaves me with y plus 4. So looking in my denominator, my excluded values are y cannot equal negative 5 and negative 4. Now, some of us were saying 0. 0 would be if there was a 3x over there. Then 3x cannot equal 0. But since there's not an x, we can't say 0. When I'm looking at this, I see that there is a y plus 5 in the numerator and the denominator, so those can cancel, which leaves me with, if I multiply my coefficients, 35y minus 4 over 30y plus 4. And we need to remember we can still simplify this. So what goes into 35 and 30? That would be 7. So my final answer would be 7 over 6 times y minus 4 over y plus 4. Okay. Some of us on this next one were not very careful factoring my numerator of the second fraction. It's what multiplies to 5 and adds to 6. So this would be x plus 5, x plus 1. As I say before, you have to be careful when you're multiplying things with 6 and 5. Those ones can be tricky. So it matters what order you're doing. Okay? And I really liked what some of you did. You wrote out x cubed as x times x times x. So I'm going to do that. And x squared is x times x. So I'm going to do that. I liked how y'all did that. Okay. So my excluded values are x cannot equal plus or minus 5. It's coming from there. And then do you see how we have an x in the denominator? That's when I would have an excluded value of 0. Now I can start canceling. X plus 5, x plus 5. There's not an x minus 5 in both, but I do have, let me change colors. I have an x in the numerator and the denominator, another x in the numerator and denominator. So that leaves me with 3x times x plus 1 over x minus 5. And if you wanted to multiply that out, then that's perfectly fine, but I'm not going to do that. All right, now with division, pretty much everyone remembered that the first thing I need to do is change it to a multiplication problem. So x squared plus 10x plus 16 over x squared minus 6x minus 16 times x squared minus 64 over x plus 8, and then we factored, and overall, I think we did pretty well on this problem. So that would be x plus 2, x plus 8, x minus 8, x plus 2 times x plus 8, x minus 8 over x plus 8. Some of you got really crazy with your canceling though. So you can only reduce one thing in the numerator denominator. So like there's one x plus 2, there's another x plus 2. There's an x plus 8, so I can cancel the x plus 8. There's an x minus 8, so I can cancel the x minus 8, which leaves me with an extra x plus 8. That one x plus 8 in the denominator does not get rid of both of the ones in the numerator. So my answer is x plus 8, and before my canceling, I had x can't be plus or minus 8 or negative 2. All right, same thing here. We are going to have to do this. The main thing we messed up on in this problem was that these two original denominators, you have to use the x box to factor. See how your a is not 1, it's 2? That means you're going to have to do x box. Once again, we have that 5 and 6 showing up, so we just want to be really careful that we're choosing the right factors when we do that. So I'll just do the x factor ones. So x minus 5 times x plus 2 and x minus 2, x minus 3, because I'm multiplying to a positive 6. Okay. Now these other two are x box, so I'm just going to do that on the right side of the screen. So the first one is what multiplies to 10 and adds to negative 11, which would be negative 1 and negative 10. So if we put that in the box, I would have 2x squared 5 negative 1x negative 10x. Remember, we're just rewriting those terms from the original. And then I take out GCS. We know how to do this. And remember, the sign comes out from the diagonal. Or you could think of it as multiplication. So that means my first denominator would be 2x minus 1 times x minus 5. And if I do the box for this next one, it would be what multiplies to 6 and adds to negative 7, which would be negative 6, negative 1. Draw our box. 2x squared. Rewrite your middle term. Three. This is the sloppiest box ever, sorry. And remember, if I check with multiplication, I should get back to my original. So that's what would tell you if you didn't do the x box that your answer is wrong, because when you multiply it out, you don't get back to your original. And this makes me happy because I have a 2x minus 1, and a 2x minus 1, an x minus 3, an x minus 3, x minus 5, x minus 5. So I end up with my answer being x minus, whoops, just kidding, x plus 2 over x minus 2, and x cannot equal 1/2, 5, 2, or 3. All right, that's it for this section.